Now, so far what we have looked at is addition, subtraction, and multiplication with these polynomial functions. We've gone over how to add two together, how to subtract two together, and how to multiply two or more together. Now, what we're going to be looking at today is dividing. And we're going to use long division. We're going to use long division to divide two polynomial functions. But before we get too far into dividing polynomial functions, we're just going to use long division on 29,682 divided by 13. I'm going to write that a little bit more spaced out. So this here is not something you've done for a while. You've done this before. You did this in Algebra 1 and before. It's just been a while since you've actually written out long division, done long division by hand. Because most of the time at this point, if I'm dividing two numbers, doing 29,682 divided by 13, I would just type it into a calculator. But we can still do, I mean, if I really just wanted to know the answer, we could type this in a calculator and figure it out. But what I'm wanting to do with this here is I'm wanting to go back over the steps of how we would divide something by long division. Well, when we divide by long division, we're seeing what times 13 would really at first would give me 2. Well, there's not a number that multiplied by 13 that would give me 2. So we're seeing what number, or how many times, let me rephrase it that way. How many times will 13 go into 29? Twice, yes? And what do I do with that 2? I put it over the 9, yes? Then what did we do next? Over the side, we do 2 times what? 13. 2 times 13 is? And then what did we do next? We subtracted these two here. Well, 29 minus 26 would give us 3. It gave us 3. Okay. Now, as we're thinking back to long division, our next step would be to do what? We bring down the 6. Yeah. We bring the 6 down. And we do the same steps. And we say, how many times does 13 go into 36? Or what times 13 will give us something close to 36? 2. So again, off to the side, we would do 2 times 13, which would give us 26 again. And again, we would subtract, leave us with 10. So we know it's going to be more than 2. Yes? 9 would be too big. Let's try 7. So we can do 7 times 13. Well, 7 times 3 would be 1, carry the 2. 7 times 1 is 7, 8, 9. Let's see what 8 is. 8 times 13. 8 times 3 is 4, carry the 2. 8 times 1 is 8, plus 2 is 4. So we can do it one more. It would be 8 and not 7. Then we would subtract. And we would left with 4. And lastly, we're going to bring down the 2. And we want to see how many times does 13 go into 42. 4 times 3 is 2, carry the 1. 4 times 1 is 4, plus 1 is 5. So it's going to be 3. 3 times 3 is 9. And 3 times 1 is 3. And if we subtract this here, we're left with, well, this turns into a 3. So we get a remainder of 3. Well, with 3 over 13. Because when we do a remainder, we always take whatever the remainder is over what we were dividing it by.
It's so weird to do with non-familiar numbers that you're multiplying by hand. Or 13.
Yeah, 13 is a little bit weird. It's a weird number, but the overall process is coming back to you, yes? How we go through and do this. Okay. Now, keeping that in mind, we're going to do the same thing when we divide polynomial functions with long division. Now, you don't have to write this down. The gist of what this is saying is when you divide a polynomial function by a non-zero polynomial divisor d of x, you will get the whole parts, the parts that divide out evenly, with a r of x. This is our remainder over what our dividend or our divisor, what we divided it by. I-V-I-S-O-R. So just like what we did with dividing by 13, because we had the whole number, the number that divided into it evenly, that came out evenly, and then our 3 over 13. That's our remainder. And it's going to work out very similarly. It's going to work out almost the exact same. So let's look at this first one here. Let's look at this first polynomial function we're going to divide with long division. Well, what was the first thing we did with our first problem when we divided by 13? When I use long division, we always start with this here. This, I think some refer to it as a house or the garage or just the different names. But this is always how we start out. Now, this here goes inside. X cubed minus x squared minus 2x plus 8. It has to be written in standard form. Both of these here, when we do long division, they have to be written in standard form. What we'll go over tomorrow is synthetic division. It has to be written in standard form. So what is the biggest exponent for this here? 3. Since 3 is the biggest exponent, I have to have the exponent of 2, 1 or just a variable, and a number. I have to have them all. Okay? And we'll come across a case where we don't, and we'll cover that in a minute. Now, what are we dividing it by? We're dividing it by x minus 1. Now, the goal for dividing is everything that's inside that garage or house, however you want to define it, everything that is inside here, we want it to simplify down so that the power is less than 1. We want to get it so we can't divide anymore. Now, to do that, I want the first term to cancel. I want to see how can I cancel out the first term. Well, to cancel out x cubed, I would need to be able to subtract x cubed from it, yes? Because x cubed minus x cubed would give us what? 0, yes? Anything subtracted from itself is 0, yes? So, to do that, what can I multiply x by to give me x to the third? What times x would give me x to the third? X what? X squared, because x squared times x would be x to the third, yes? That's what we're doing from one step to the next. We're trying to see what can I multiply x by to get the first term or the term that is in front to cancel out. Okay, so now we're going to multiply. x squared by x minus 1. Well, x squared times x is going to be x to the third. Because when we base are the same, we add the exponents. Now, x squared times negative 1 would be negative x squared. Questions on this here so far? So this goes right down here. Okay, now what was our next step once we kind of had the number under it for our first example? We did what? We subtracted. And that's what we do next. Now, x cubed minus x cubed, cancel. A negative and a negative make a. So negative x squared plus x squared is 0. It's not always going to work out that they both cancel, but here it did. Here it did. Any questions on this so far? What did we do next for our first example of long division after I subtracted once? We did what? We dropped down to negative 2x. How many terms do I have here? 2, yes? How many do I have here? I just have negative 2x, don't I? I have to bring the 8 down with it. Now, in most cases, this here is a little bit odd, but if the x squared hadn't canceled out, we would have been fine bringing 1 down because I would have the x squared and the x term. I would have had 2 terms. But because both of these canceled, I had to bring down 2. Okay. Any questions on any of this here so far? Does this feel very similar to long division, what we just did when dividing by 13? I mean, it's different that we have variables, but the process that we're doing is very similar, isn't it? So what times x will give me negative 2x? Negative 2. So we'll multiply. We'll do negative 2 times x minus 1. Well, negative 2 times x will be negative 2x, like we wanted, yes? Be plus 2. Well, negative 2x minus negative 2x, these two here will cancel. Is that what we wanted to have happen? Yes. 8 minus 2 is 10. Now we're done. Whenever the degree of what is left over after we subtract, what is the degree of 6? 0. There's not an exponent. There's not a variable with an exponent, is there? Whenever there's a number by itself, its degree is 0. We're going to keep doing these division steps of multiplying then subtracting until the degree of what we have left is less than the degree of what we're dividing by. Because what we're dividing by, this x minus 1, its degree is what? 1, yes? Whenever I get a constant term, I'm done. Because I cannot divide it any further than this here. Any questions on this here? Okay, now let's look at what the answer is. Because we got x squared minus 2, yes? Plus 6 over what? And that's it. Any questions on anything we've done so far? We good with this here? Yes? What did I just do? I took a polynomial, a starting polynomial that had a degree of 3, yes? Because this thing up here, this thing right here has a degree of 3. Yes, the biggest exponent is 3. What is its degree now? Using division, I can take a polynomial with a higher degree and move it down one at a time or two. I can decrease that degree by dividing, yes? This is going to be the key in solving these higher degree polynomials. We're not going to come up with new ways to solve for anything. There's a few for cubics, but anything like 4th degree, 5th degree, 6th degree, we're not going to come up with new methods to solve it. We're going to use a lot of the tools that we already have and division to bring them down to something that we do know already. Because if I can get it down to a degree 2, we have the quadratic formula, don't we? So if I can get it back to a degree 2, I can use that to solve out. So that's what we're going to try to do. But before we get there, let's use long division again. We're going to do long division again. Now the first main thing is we're going to build the little house. And this is what we're going to divide, put inside. So we have 2x to the 4th. Plus what? Plus cubed. Plus. Am I missing a term? Because we have 5, 4, or sorry, we have 4, 3. We need a 2, yes? Because we don't have an x squared. I'm going to add x squared in. What number should I write in front of it? How many do we have? I don't have any x squareds, but I can add it in by adding in 0x squared. Did I really add anything into this equation? No. But we need it there. We need it there. Okay, now we have everything else. Plus 5x minus 1. So with long division and synthetic division, if there is a term missing, so here we were missing because we had our 4th, had the 3, we were missing the 2, we added in a 0x squared. We have to add it back in. Now let's see what we're dividing by. X squared plus 3x plus 2. Now if you're wondering, do I have to do it to this one also? Yes. Because if it had just been x squared plus 2, I would have had to write it in as x squared plus 0x plus 2. We need all the terms. Okay. Any questions on this here so far? Now, our first main step after getting it set up is trying to eliminate the first term. The term inside farthest to the left, which would be 2x to the 4th. So the main question I ask myself is what times x squared gives me 2x to the 4th? Is 2, I need the 2, because 2 times 1 would give me 2, yes? So I have x squared. Well, how many more x's do I need? 2. I need x squared, because x squared times x squared would give me x to the 4th. So we have to do 2x squared times x squared plus 3x plus 2. We have to multiply this out. Well, we know one already. 2x squared times x squared is 2x to the 4th, because that's the one we want. We need that first term to be 2x to the 4th. Now, 2x squared times 3x, well, 2 times 3 is going to be plus 6x cubed. 2x squared times 2 is plus 4x squared. Any questions on this here? Any questions on anything we've done so far? Now we subtract. Well, 2x to the 4th minus 2x to the 4th, these will cancel. These should always cancel because that's what we want. We want that farthest left term that we're dividing into, this one here, to cancel out every single time. Now 3x cubed minus 6x cubed, negative 3x cubed. 0x squared minus 4x squared, negative 4x squared. Any questions on this here so far? Now what do? Bring down the 5x. Plus 5x. So we bring the sign with it. Okay. I'm going to erase this here so I have some more room. Okay, the question comes again. What times x squared will give me negative 3x cubed? Negative 3x, yes. I started over 3 terms, didn't I? I lined up the x squared because that worked out the first one, yes? But wait a minute. This next one had an x in it, yes? Is that above the term with x? What do we expect this last one to be? Is it going to have a variable? No. If you line these up to begin with, I'm going to put this caveat in here. X squared with x squared, the rest of the terms will line up. That there's kind of a hint to see what is the variable's exponent going to be. Well, heck, I have 3 terms here, yes? 1, 2, 3, I'm starting here. That'll help you also. Well, maybe that's just this one here. How many terms do I have here? So I started over 2. This one here would have been 0x, but it works out. Okay, let's keep going. So we're going to multiply negative 3x by x squared plus 3x plus 2. Well, negative 3x times x squared will give us negative 3x cubed. That's what we want. Negative 3x times 3x is going to be negative 9x squared. And negative 3x times 2 is going to be negative 6x. Any questions on any of this here so far? Negative 3x cubed, well, negative and negative make a positive. But this all becomes 0, yes? So here, negative and negative make a positive. So negative 4x squared plus 9x squared will be, bless you, 5x squared. Here, negative and negative again would make a positive, so we get plus 11x. And lastly, we bring down the negative 1. Any questions on any of this here thus far? Any questions on any of this here thus far? Okay. Last time, what times x squared gives us 5x squared? Positive 5. This here would give us 5x squared plus 15x plus 10. I'll scroll back up here in a second. Any questions on this here so far? So when we subtract these here, negative, well, 5x squared minus 5x squared will cancel. 11x minus 15x is going to be Negative 1 minus 10 would be negative 11. So looking at this here, what is the degree of negative 4x plus 11? Or minus 11, sorry. Because x there is to what power? The first. Whenever we have a variable that doesn't have an exponent, it's always to the first power. But the bigger question, is the degree of this less than the degree of this? Yes. So can I continue dividing? No, we're done. So our answer is going to be this here. I have to add to it what? Negative 4x minus 11 over x squared plus what? Because we take the remainder and put it over what we were dividing by. We put it over what we're dividing by. Any questions on this here? We're ready for another one because I feel like we need to do at least one or two more. Yes? Okay. So we're going to start this up the same way. This is what goes inside, so our first term would be 4x to the fourth. Then what? Okay. Plus. Then what? Okay. So as you can see here, we can have more than one term missing, so we can have multiple. We have x cubed and x squared that we had to fill in. But that's fine. Any questions on this here so far? So let's see if that little caveat I threw in on the last problem will help us out. How many terms do we have here that we're dividing by? 3, don't we? X squared, x, and 2. So if I go over 3, so x to the fourth, x cubed, x squared, this would be our spot, yes? So if this thing worked, it means we would be multiplying first by something times x squared, yes? So let's see if that works. So what times x squared will give me 4x to the fourth? 4x squared, isn't it? So because I had 3 terms here, I'm going to have to go over 3. It gave me the x squared, didn't it? Well, it also means my next one's going to be something with x and then a number, yes? So it kind of helps us out. Now, it could be that it's 0, or we don't have a number, but it kind of gives us the variables. So let's start this off. Because we'll have 4x to the fourth. We have to have that one. Because 4x squared times x squared would be 4x to the fourth. Now, 4x squared times negative 3x. 12x cubed. And 4x squared times negative 2 would be negative 8x squared. And once we type that in, we're going to subtract. Now, 4x to the fourth minus 4x to the fourth is 0. Well, negative make a positive, yes? So 0 plus 12x cubed is 12x cubed. Well, again, negative negative makes it positive, so then we have 8x squared. And then like last time, we bring down the plus 5x. Any questions over this here? Any questions on anything we've done so far? Okay. Now we're going to go back to the same question. What times x squared is going to give me 12x cubed? Plus 12x. 12x. So we're going to do the same thing. We're going to multiply 12x by x squared minus 3x minus 2. Well, 12x times x squared is going to be 12x cubed. 12x times negative 3x will be negative x squared. Then we'd have minus 24x. Yes. And then, like the last one, we're going to subtract. Well, 12x cubed minus 12x cubed will cancel. Negative and negative will make a positive. So we have 44x squared. Negative and negative make a positive. So we have plus 29x. And lastly, we bring down the negative 4. Last but not least, what times x squared gives me 44x squared? 44. Well, 44 times x squared is going to give me 44x squared. Now, 44 times negative 3 is going to be 133x. And 44 times negative 2 is going to be negative 88. Are we good with this here so far? Any questions on any of this here? So we subtract 44x squared minus 44x squared. These would cancel. Well, negative and negative would make a positive. So 4 carry the 1, we end up getting 164x. If you do 29 plus 133, and it will give you 164. Not 64. Going the wrong way. 9 times 3, or 9 plus 3 is going to be 2, carry the 1. It should be 162x, not 164. Because that would have been 31. Now here, a negative and negative would make a positive. But negative 4 plus 88 will be plus 84. And I continue dividing from here. No, we're done. We're out of terms. So we bring down our 4x squared plus 12x plus 44. Because that will be part of our answer. So what are we going to have to add to it? 2x plus 84 over x squared 3x minus 2. Any questions on this here? Any questions on anything we've done so far?
For 133, I got 132.
Yes, thank you. Thank you. Okay. So that'll just change our numbers slightly, because this should be 161. Yes? Thank you. So it should be 161, not one. It should have been 132, not 133, which would have given us 161 in the end. Any questions on this division here, using long division? Let's see, what do we have left? Let's finish it off with this one here. This one here will be the last one we do. We don't have to add any zeros this time. Okay. So what times 2x squared, or sorry, what times x squared, what times our first term will give us 2x to the fifth? 2x to the third, or 2x cubed. Now on your paper, I do this off to the side. I'm going to have to do this right here because I don't have room. X squared minus x minus 4. We're going to have to multiply through. Well, 2x cubed times x squared will give us our 2x to the fifth. 2x cubed times negative x will give us negative 2x to the fourth. And 2x cubed times negative 4 would be negative 8x to the third. Any questions on how we multiplied this out? Okay, so we line it up. And we're going to do what? We're going to subtract. Well, 2x to the fifth minus 2x to the fifth would cancel just like we wanted. X to the fourth minus negative 2x to the fourth. Well, a negative and negative would make a. So x to the fourth plus 2x to the fourth would be 3x to the fourth. Again here, a negative and negative would make a positive. So negative 15x cubed plus 8x cubed would be minus 7x to the third. Lastly, we drop down our negative 2x squared. Questions on this here? Any questions on any of this here so far? Okay. So the bell's going to ring here in a second. So if you want to see how this finishes out, you can stick around. If not, if you feel comfortable with this, you can go on. But what we'll look at next is what times x squared gives us 3x to the fourth. Well, that'll be plus 3x squared. So if you want to stick around, you can. If not, that's fine. Now, when we multiply through, 3x squared times x squared would give us 3x to the fourth. 3x squared times negative x will give us negative 3x cubed. And 3x squared times negative 4 will give us negative 4x squared. And at this point here, we're going to subtract, and these here would cancel. Negative and negative would give us a positive, so that we get negative 4x cubed, negative, negative, minus 2x squared. Drop down to 10x. Now this here would be negative 4x Negative 4x times x squared would be negative 4x cubed. Negative 4x times negative x would be plus 4x squared. And negative 4x times negative 4 would be plus 16x. And again, we would subtract. These two here would cancel. Negative 2x squared minus 4x squared would be negative 6x squared. 10 minus 16 would be negative 6x. Bring down the negative 24. Well, this here would be negative 6. This here would be negative 6x squared, because negative 6 times x squared would be negative 6x squared, yes? Negative 6 times negative x plus 6x. And so here, negative 6 times negative 24 would be plus 24. And when we subtract, these here would cancel, and we would get negative 12x minus 48. And we would end up simplifying it down, giving us our answer. Let's see, your negative 12x plus 48. And we could say plus 12x minus 48, not plus 48, over x squared minus x minus 4. And that would have been our answer.